A feature present on the Northern Utah WebSDR, and also many, but not all other WebSDRs, is that of DSP noise reduction. This noise reduction is the same as that found on many amateur transceivers made in the past several decades, so its operation should be familiar to most, but it's still worth taking a closer look at how it works, and also its limitations. Any audio noise reduction relies on the fact that while noise is random, the desired signals, whether they are voice or CW, are not. This is a pretty good assumption, as CW signals, and many digital modes, are more or less single tones that get turned on and off, or moved around in frequency or phase to convey information. In some ways, it's fortunate that the white noise we hear on the bands is pretty much random, as that makes it easier to distinguish desired signals from the noise in the ways that we just mentioned. If you have a bunch of truly random numbers, say between -10 and +10, you'll notice something interesting. The average of those numbers will hover around 0, which is to say that over time, they tend to cancel each other out. This is also true of white noise. It isn't on any particular frequency, which means that on average, its energy is spread out all over the place. For voice or signals like CW, this is not the case. When we speak, our voice box buzzes at a particular pitch, and the timbre of our voice determines how many harmonics are present and how strong they are. In other words, our voices are a really complex series of tones. These tones, like a CW signal, have their energy concentrated on one or just a few frequencies rather than being spread out all over the place. What this means is that if we were to average the energy from audio frequencies, we would find out that while the noise would statistically disappear, the components of the voice, or the tone of a CW signal, did not. One way that this seemingly magic act can be accomplished is by using the least mean squares algorithm to filter our audio. We won't get into the math here, but all we need to know that it has the ability to adapt quickly and form filters. With random noise, there's no single frequency at which it can tune itself and selectively pass energy, which means that truly random noise will be reduced. Conversely, components of voice-speech, CW, and some data transmissions are not random, and the algorithm will quickly form filters around the frequencies that these sounds produce. When the noise reduction is on a low setting, the aggressiveness of this filtering is minimal, with the effect that the noise is reduced somewhat. But if the noise reduction is turned up, this effect is more intense, and the result is less noise, but more artifacts, as the algorithm is slower to adapt, and it does more aggressive filtering, often causing a somewhat hollow or voices in a barrel sound, as it randomly tries to form shifting bandpass filters based on the noise. All of this explains a reality with such noise reduction filters. They can work really well on making a medium to strong signal sound much quieter. But they struggle to dig out the energy of a voice that is buried in the noise. As the signal gets weaker, it stands out less and less from the random noise energy that we're trying to eliminate, which is why we must often resort to stronger filtering and suffer more artifacts in the meantime. Because voice energy is constantly changing in frequency, it gets harder and harder to lock on to it than, say, a CW signal, which, with its constant pitch, can often be recovered very nicely under such conditions. One seeming artifact of the noise reduction is that it can reduce highs. On the Utah SDRs, some preemphasis is already built into the noise reduction to combat this effect, but one can check the high boost box just above the DSP noise reduction dropdown if you want more boost. And remember, you can do this even if you aren't running any noise reduction. Finally, remember that if you are making recordings, any noise reduction or audio processing that you might be running will be present on those recordings when you play them back, something to keep in mind. Thanks for watching.